And I think I'm sharing a screen. I am sharing a screen. Excellent. Okay, so just to remember where we left off, our the task that we're working on is we're trying to figure out, have the machine calculate for us a reasonable route. We have to visit each one of these hotels. We have on this worksheet the data that tells us road distances between each hotel. So look at this number right here. It says the distance between the Sheraton in Los Angeles and the W in Scottsdale is 385 miles. So using this data and using arrays, we're going to solve the problem. I mean, solving the problem maybe is too strong of language, but we're going to have the computer generate a route that's not terrible. It'll be a little dissatisfying once we actually get it done, and we will get it done today. You'll be like, I could have done better with a pencil and a map, and that's true. But at least we'll be generating something, and it'll be pretty reasonable. All right, so just to kind of remember, we in computing lingo, we refer to this thing as an array, but it really is an array of something. Just like any time we use the word array in the English language, it doesn't make sense to say an array unless you either say what the array is, or unless it's understood by your audience what it's an array of. And when we're talking about VBA, when we say an array, it's really an array of something. And what is that something? It is an array of variables, right? When we declare an array, we are making a potload of variables all at one time. And who can tell me what's the big benefit about using an array to create several? Let's say you only needed 10 variables. I mean, it's only 10. I mean, you could copy and paste to create 10 lines and call one variable, var1, var2, var3, var3, or whatever, and have them all numbered. What's the big advantage to having an array versus individually created variables? It's not just that they're easier to create, you can create them all at once. Like once you actually have them made, there's a big benefit to using an array of variables over just a bunch of variables. And what's the big advantage? What's the flexibility that you get by having an array of variables? And the big difference here, what's the real benefit is that when you have a variable that you've just given a name to, you have to refer to it by that name, and you've got to like write out that name in the code. But when you have an array of variables, I am referring to the array. Let me just go ahead and we'll run our code here and stop it here. Oh, by the way, we're picking up where we left off. If you didn't follow along like all the way, or you want to pick up exactly where I am, go to today in the on the blog. Is today the 23rd? Yeah. And then just download Starwood Fall 23. That's where we're starting. And that should be just like where we left off here. It's the same file that we left off with here. More arrays. Okay. So I'm going to go ahead and run this. This is getting our arrays configured and set up. So I'm going to run this. And if I had a variable like x, and I wanted to see what the value of x was right now, I could just say x. But the point is, I have to spell out that whole thing by its name. And if I had a different variable, it'd have a different name, it'd take a different line of code to do that. But for my array, like hotel, it's a combination of the name and an index number. And now I can put any expression here that evaluates to a valid number for that, identifying an element in that array. And so I could have a call to a function. I could have some other variable that's counting. And it's exactly what we're doing here is because we can identify each of those variables individually, we can create a loop here that goes from 0 to however big the array is. And then each time through the loop, we are referring to a different variable by using a different, like the different value of this index. So I can have one line of code that with the help of a loop can refer to every single one of those variables. I don't have to refer to those variables by their whole name, by the name of the array, and then some expression that gives me the index for that array. And that allows me a lot of power with working with loops and my variables in the array. Questions? How comfortable are you with what we did last time? We created a couple of arrays. They're dynamic arrays. We get their size. It might be a good idea just to kind of look through this. A couple of things we did that were new last time we were together. we declared arrays, and you can do this not with just arrays of variables, but regular variables as well. We declared them outside of the subprocedure, put them at the top of the module. That makes them have module scope. So any subprocedure inside this module will be able to refer to those variables. Just how comfortable are you with that? 0 to 5, declaring variables at the top of the array so they're available more broadly. Now, an interesting thing that we did here when declaring this array, who can tell me what it means to declare an array without putting the size of the array? That creates what's referred to as a dynamic array. What's the benefit of that? Someone could just say it out. Right. So when we declare an array without saying how big it's going to be, before we use it, we will have to redim it so we can calculate instead of having to have a hard-coded value that says how big it's going to be. We can have an expression in here that calculates how many elements we want that array to be, or calculates what the upper limit of that array is, the upper boundary. And so in this case, we're actually looking at our distance sheet. We're starting in row 2, column 1, doing end XL down. So we're like starting here, doing control down to figure out where the end of our data are. And then we use that number to figure out what our array should be. So this is 37, but we really only have 35 or 36 elements, but arrays start counting at 0. So the number we're actually after is 35. So we're finding out what row the data ends on, and then we're subtracting 2 off of it to get how to declare the array. The thing to realize is that we can't just say dim and do that size, because all of my variable allocation, like requesting data for all those variables, happens before the code starts to run. Even though I can put dim statements later in the code, the interpreter says, all right, you're going to run this subprocedure. Let's find out all the code, like all the variables you need, and it declares them, allocates the memory before any other code starts running, which means that this part can't calculate on a normal dim statement. But if we've declared it as a module level variable, we can then redim it to that size, and this then allows us to calculate a value and decide how big to make it. And so by making it a dynamic array, we can look and see, hey, how big should this array be? Allocate that much memory, and then we're ready to move on. Question? So when you redim it, the question is it just for this module? Is it for everywhere? And the answer is it's for everywhere. So we have this one array structure, this array of variables that's available through every place. We will redim it in one place, and then we've changed that location and we've changed it how it is in memory. Every other subprocedure in this module accesses that same memory. Yep, great. So we're calculating all of these. So now we did something kind of towards the end that was a little bit different. We said, oh, instead of just declaring how many variables we want in the array, we're going to give you 2 dimensions. So if you can think of this as how many rows and how many columns are going to be in the array. And you could have 3 dimensions. You could think of it as a cube. You could have 4 dimensions. I don't know how you think about 4 dimensions, but you could think about it as 4 dimensions. What that means is however many numbers you put here when you dim or redim the array, you have to supply that same set of numbers anytime you want to access it. Now it takes, for my dist array, it's going to take 2 indices every time I want to refer to it. And that's handy because like this data is really logically organized as a grid. And so having that data set up as a 2-dimensional array will really facilitate working with this data. Okay. So on that idea of multi-dimensional arrays, show me where you are, 0 to 5. 5, 5, 4, 4, 4, 4, 4, 4. Okay, yeah, it's kind of a new thing. We've just done it a little bit, and it was kind of at the end of class. So we declare a couple of variables that we'll use to manage our loops. We have one loop here that initializes our hotel array. So hotel is an array of strings. And we are now saying, hey, we've got a loop here. We're taking x from 0 to the upper boundary of hotel. Ubound is just a function that tells me what's the upper boundary of this array. And then we are, as we go through this loop, we're reading a different value off of my distance sheet. So I'm going to start when X is 0, I'll be starting looking at row 2, column 1. And so the first value I'm reading is right here, row 2, column 1. The next time through the loop, it reads this one, and it puts it into the corresponding slots of the array. So after that loop runs, we've really done this. We've taken all of these values. Let me come over here to my arrays sheet, which is just where we're thinking about. Of course, we're not actually referring to this sheet. This is just a representation, a visual representation of what's happening in memory. Once we've initialized, run through that loop, we've actually put all these values into the hotel array. Of course, it starts off with a bunch of zero-length strings. It's just the default value for string variables. We've also declared the route array. It starts out with a bunch of zeros, and we are putting into it -1. So once we've gone through and taken X from 0 to the upper boundary of the hotel array, which is the same size as the route array, we will actually put the names of those hotels in, and we will put in -1. Why are we putting -1 into the route? And this route is going to hold we're just going to put the index number from over here. So ultimately, when we go to build this, we're going to say start in Salt Lake City. So we're going to put 1 there. We're going to say go to Las Vegas next. We'll put a 7 there. I forget where we go after Las Vegas. But this is how we're doing it. So someone tell me, why are we putting -1? Why are we going through the effort to fill this thing up with -1s? I mean, it's ultimately, we're going to replace all of those anyway with a valid hotel number. Yeah, go ahead. Somehow we're going to have to look at this route and ask ourselves, have we been to that hotel yet? And since 0 is a hotel, if it's full up with a bunch of zeros, every time we ask, have you been to this hotel yet? It's going to say, yeah, you've been there, even though we really haven't. And so by putting a bunch of -1s in here to get us started, what we're saying is, yeah, don't accidentally think you've been to the Sheraton Los Angeles Downtown Hotel, hotel number 0 yet. So we're making sure that our array starts with no valid hotel numbers in it. All right. Then we said, all right, we're going to have to load up our 2-dimensional array. So every time we refer to one of the variables, why do I have a capital Y for, I'm going to change that Y to lowercase. Every time we want to refer to our dist array, which is going to be holding all of our distances, we've got to give it 2 indices. And so if we think first about this inner loop, we're saying, X is going to go from some starting point up to the upper boundary of our hotel array. I'm not even talking about the hotel array. So why am I looking at the upper boundary of the hotel array? And the answer is, I've got the same number of hotels as I have elements in my route as I have in each dimension of my dist array. I could say, well, instead of the upper boundary of the hotel array, let's look at the dist array. The trouble is the dist array is multidimensional. It's got 2 dimensions. So I have to tell it which dimension I'm interested in. And so I'll tell it I'm interested in the first dimension. That'll give me the same thing because I've used that size to redim that array. So whether I say for as big as the hotel array is or particular dimension of my distance array, it's the same thing. You could leave it the same in your code. You could change it. It just won't matter. But if I do that here, I probably do want to be parallel on both of these. Okay, so whatever value we have for X and Y, we're going to read a value off the sheet and write it in there. We're going to execute this thing 36 times. So Y is going to start at 0. And we're going to execute this. Well, it's actually not 36 times. Y is going to start at 0. And so the first time through, X is going to go from 1 to 35. So it'll go 35 times. And it's going to read this set of values right off that worksheet. Tell me if it's worth going through the code to understand why it pulls those values. How many are saying, hey, I wouldn't mind seeing the explanation of why it reads that sheet, those values on the sheet? Okay. So if we look at this, what we're saying is, let's kind of just follow these values through. In fact, let's go ahead and put a breakpoint here. I'm going to run this code, and then we'll step through it. Let me go ahead and bring up my locals window. view locals window. I know that's tiny for you. So, so right now, y is 0. Now, y is 0 because it's just been initialized to 0. This hasn't executed yet, but that's going to execute like right now. I'm going to step through this. So just use F8 to step through this. Okay, so now x is 36. Why is x 36? Well, x is 36 because it's just the leftover value from running through this loop. So we're going to get to this for statement, and it is going to put a new value as the starting value for x. What is it going to be? Y, which is 0 plus 1. So when I execute this line, it should change x to be 1. And now we can see over here, if you squint, you can see that's now 1. So now the first time that we're writing to our array, we're writing to the 0th row and the first column. So if we think about this on our array representation, row 0, column 1, we're about to write a value to that right there. Where are we getting the value? Look at the distance sheet, and in the cell y plus 2, y is 0, plus 2 is going to be 2. So we're looking at row 2, column 3. And so it's reading the value off of row 2, column 3 of the distance sheet, and it's putting it in that slot in the array. Well, I'm showing you that we're putting 691 in there. So row 2, column 3 on my distance sheet better be 691. And it is 691. And so we're reading off of this sheet, and then we're plugging into this spot in the array. And again, remember, this is not really the worksheet we're looking at. It's a visual representation of that memory structure. We've got, how many variables do we have? We've got all these variables. Each one of these cells represents a variable in the array. We're writing to one of them right here. The next time through the array, I'll just advance here with F8. We get to the next. As soon as we execute next, you're going to see that x goes up by 1. So now x is 2. Y hasn't changed. Y won't change until we get up to this top loop again. And so now we're looking at the same, we're reading from the same row, writing to the same row, but x has gone up by 1. So the next variable over in our array and reading from the next column over from the worksheet. So we're going to be putting 374. We're going to write something to right there. And what is it? 374. The next time through the loop, x will go up and we'll read from here and write to here. And we'll go right across that until we've gotten to the size of the array. Now, you just go ahead and put a stop right here, and we'll run to there. So now we've gone through that. X is 36, and we should be able to look at our dist array now. Our dust array? Our dist array now, looking at row number 0, column number 1 should be that 691. Column number 2 should be that 300 and something. And we should be able to go all the way up to 35, which should be the very last value, 1139. And there's that 1139. Probably makes more sense to look at it here because this is the sheet we read it off of. There's that 1139 right there. So we've gone through that code and it has read off of this whole worksheet and dropped those values on into the array. But the whole rest of the array is blank. So if I look at anything on row 2, that's still going to be 0 because I just haven't written to it yet. Why is it 0? Well, it's an array of integer values, and all numeric variables start out at 0. So it's got 0 because that's the default value for the variable type. Y is still 0, but now we're going to continue on through this code. We've just gone through this loop 36 times, and now we're going to step from here. So we're going to hit the, I think we are, I hit F5 instead of F8. It's actually gone through to, I'm going to stop that and try it again. Stop, start again, F5. Okay, so X is 0, Y is 36. I'm going to step with F8. And that's going to say, great, we're now getting to the next that's for that Y. Now Y is going to go up by 1. And we're starting the X loop over again. But this time, instead of starting at 1, we'll start at 2 because Y is 1. So X is going to start at 1 plus 2, or 1 plus 1. So we'll start at 2. So I'll execute this line. You'll see the X now go to 2. And so with y of 1, x of 2, we're going to be writing to this location right here, where y is 1, x is 2. And remember, we're adding 2 to each of those dimensions. So where are we, as we look at the distance sheet, so where are we reading from? We'll be reading from this value right here, y of 3, x of 4. And then we'll continue to go right across there. We'll finish off that loop, written through all of them, and now we're ready to go up to the next step through y. So we hit next, y goes from 1 to 2, x starts again at its starting point, which is changing each time because as y gets bigger, there's less data for us to read. And then we'll just continue executing through that. You just kind of hold that down and watch it go 24, 25, 26, 27. And it goes through the inner loop like once, it goes through all the elements of the inner loop every time it goes through the outer loop. So at this point, we've read all the way to 36. We're starting now. Okay, so we've read a few of these. Let's look at, we should be able to look at this one, where y equals 4, x equals 5. So dist 4, 5, there should be a value there. Take a quick peek and see, there it is right there. There's that 10 right there we're reading. But where we've stopped in the code, we haven't read the rest of these. And so if I look at y is whatever it is, x is 1 larger, if I look at this number 6 here, that'll still be 0 because we just haven't gotten there yet. But by the time we finish all the way through here, we now will have filled all of this data into our array. So no matter where we look in this array, as long as the second argument is larger than the first one, we'll be looking in this top diagonal. We should be able to see any of these numbers. Come here to, say, row 30, column 33, and we're getting a value. If I look for row 30, column 30, that's right on the diagonal. We haven't written to any of those. That should be 0. If I look at where my row is larger than my column, row, like row 31, column 30, that's 0 as well, because that's down here in this part of the array or this part of the data that we haven't read. We've only read and put these in. Okay. Comfort level with the way we're loading this array so far, 0 to 5. 4, 4, 5, 4s and 5s. Okay. This is not simple code. I mean, it's not terrible, but like how we get here is one thing. Now, our next question is how, first of all, do we even need to fill in the rest of our array? Do we have enough information here to solve the problem? Yeah, we have all the information that there is. So why might we want to fill in the rest of this array with the numbers that correspond? And there's a couple of reasons. First one is, look, I'm using the memory anyway. So it's not like it's taking up any more memory. Those variables are allocated. So it's not going to take any more memory to put those numbers into the array. But the really nice thing is if I have this array fully specified, right now, if I want to compare all of the distances between the Westin and Long Beach and all the other hotels, I would have to go down through my array this way until I hit that diagonal line and then switch and go that way. We could do that. We could write our code to say, oh, we got to look down until the indices are equal and then kind of switch how we're doing it and go across. But if we were to take this information here and just paste it here, like if we filled in this whole other array, now, a whole other part of the array, now on one row or one column, we have all of the distances between that hotel and the rest of the hotels. And so this will really simplify our code to say, hey, we just want to, once we've identified the row that we need to read, we don't have to think about the rest of the array at all. We just have to deal with that one element of the array, that one row of the array. And so our next task is going to be to fill up the other half of this array. Any thoughts on how to do it? So if we could, so it turns out copy and transpose, if we copy this whole thing and transpose it, we can't just copy this whole block and transpose it. Because if we did a copy and transpose, we're getting these, it would just give us the other part of the array. So we could just kind of do what I did here in class, right? We could say, copy this part, paste it over here, copy this part, paste it over here, copy this part, paste it over here. And we could write something to automate that as well. Then we could just kind of read across the whole array and not change it. But what I would like to do is I'd like to say, listen, once I read it off the worksheet, I just want to write it, that one value, to the two places in the array that it belongs. So instead of doing it in Excel and then reading it all into the array, I would just like to say, listen, when I write to here, and let me go look over here in my arrays because it's easier to think of it as the indexes. When I write to 0, 1, I have to also write to 1, 0. When I write to 4, 5, I also have to write to 5, 4. When I write to 0, 6, I also have to write to 6, 0. And so it is literally just reversing the indices to get the data to go where I want it to go. And so I'm just going to do this. I'm going to copy this part right here. And as soon as I write to this location in my array, I'm going to say, great, I also want to write to the analogous position. So I'm going to write to the, just literally just swapping these indices. And I could read it from the same place on the worksheet again, or I can read it out of memory. Generally speaking. No, not generally speaking. It is always faster to read something out of like a fixed location in memory than it is to read it off of this, like go read it off the worksheet. How much faster is it? Like, would this be noticeably slower if I read it from the worksheet again? No. You're talking about a millisecond or two distance for filling this up. Not very much difference at all, but I'm going to read it from the array. How many of you think this is easier to look at if you say, like the way we've done it here, we're reversing the elements, or how many of you would say, you know what, I would prefer to see it this way, where you're writing exactly the same thing, only the only difference is you're swapping the variable. Who likes this better? Yeah. Who's like, I don't care. They're both confusing. Yeah. Okay, so now let me go ahead and take out this breakpoint and I'll run it to that one. Stop, we'll run this again. But now if I look at disk 3130, it should give me the same value as if I look for 3031. So now I've got that array fully specified. My distance array now has the distances so that if I either look down one column or look down one row, I will see all of the relevant distances to all the other hotels from whichever one I'm on. So if I'm, let's see, so where's, let's just look at this one right here. So whatever hotel number 7, that's Las Vegas. So from Las Vegas to there's one in Los Angeles, 268, 425. If I look at 7, row 7, column 0, 268, look at number 1, 425. We're doing all of those Las Vegas numbers, 286, 306. We're reading right across. We're going to get to 7. That'll be 0. That's distance from Las Vegas to Las Vegas. And now 7, 8, we're going to the next one past the diagonal. So that's between Las Vegas and whatever hotel number 8 is. And you can see we're getting that 281 value is what's showing up here. So as we just read across that one row, we're now seeing the distances between Las Vegas, the property in Las Vegas, and all the rest of the hotels. Okay, so now I think at long last, we've got our arrays configured. Our arrays are built, they're sitting in memory, they have all the data in them that we need to be able to start building out that the route, to figure out what the route is. So I'm going to go ahead and run that the rest of the way through, and we're ready to make a new sub procedure. I'm going to make a new subprocedure here called calc route. All right, and this is just going to use the next nearest NEAREST hotel algorithm to generate a route. Now we're going to start it somewhere. And let's just go ahead and start this at Salt Lake City. The Salt Lake City property, it happens to be property number 1. Now, it is entirely coincidental that property number 1 is the first one we're going to. It happens that Salt Lake City is number 1. We could start at the Westin in San Diego, and maybe we will at the end of, once we've got this running, we'll have a different start point and see what route it creates. So how then am I going to say, looking at my arrays here, let's get these starting where they are. How am I going to say, start at Salt Lake City? Like what line of VBA code do I put to say, start at Salt Lake City? Don't be shy. Like if you get it wrong, it's not gonna, it won't be physically painful. Like at the moment, like everyone is saying, I don't know. So if you say something and it turns out you don't know, you're just like everyone else. Yeah, go ahead. Exactly right. We're saying, listen, we just want to put the Salt Lake City number right here. So this array is called route. I'm going to talk about the number 0 variable in that array, and I want to put the number for Salt Lake City right there. And so I'm going to say start at Salt Lake. SLC. Route sub 0 equals 1. That is what that says. That says start at Salt Lake City. Now, it happens that what I'm doing is I'm now going to say the next location I want to be 7. But the trick is I happen to know that it's 7. I've done this problem a time or two. But I got to get it to calculate. I got to get it to figure that out. I've got to get it to figure out the 7. And so instead of having that hard-coded, and we're going to do some work with making this happen to a loop later, but let's start with it a little less abstract than having it in a loop. Instead of plugging the 7 in, I'm going to call a function. I'm going to say next hotel. And I'm going to pass it. I don't think I'm going to pass it anything. I think usually when I solve this problem, I pass it something. But there's enough information in our arrays just to figure out where we currently are. So I think I'm going to try it this time without passing it a variable. I'm just going to say, hey, give me the next hotel number. Great. I come down here, or this is going to be a function now. Next hotel. And this is going to return an integer. Wait, what are we putting into route? Route holds long. And so this is going to return a long. So we want just to put in here whatever comes back from next hotel. Okay, so step 1 here is going to be to figure out where we currently are. And looking at what we've solved up to this point, like by the time we go to calculate this, which hotel are we currently at? Yeah, we're currently at Salt Lake City. Now, it might be possible. We could pass the 1 down here. We could pass Salt Lake City down here. But let's do it this way instead. Let's just go find out where we currently are. And how do we find that out? Like, where do I look to find out where I currently am? If I look over here at the structure I have in memory here, at this point, we've actually put 1 here. So like in English, how could I figure out, how could I look at what I have here in memory and say, oh, I'm currently at hotel number 1? kind of give me kind of the steps, just in English. Don't worry about VBA, but just in English, how do I find out that I'm at Hotel 1? I'll narrow it down. You're going to have to look at the route array. Go ahead. Okay, so the first time through, I have to look at position 0. The second time through, I got to look at position 2. But because I'm not sending any information down here, it doesn't really know, it doesn't know where to look. So it's going to have to scan the array, but how would it know when it has found where we currently are? Where should I start looking and how should I go about it? Go ahead. Exactly. So if say, listen, the way that I'm building this is I'm building the route as I go this way. So if I start down here, I'm just going to keep looking. I'm going to keep kind of looking up through this array until I find something that's not -1. It's -1 or until I find something that's greater than or equal to 0. Well, that sounds like a pretty easy loop to write. So let me declare a little variable in here. Let me dim x as an integer. Now, this may be the first time we've done this, that we've got a variable here declared called x inside one subprocedure, and over here in another subprocedure, we have another one declared as x. Is that going to cause a problem? And the answer is no. It's the whole reason that I prefer to declare variables that are going to be used inside this subprocedure. To declare them inside the subprocedure is because these are two variables, two locations in memory. Each have the name x, but each are only accessible from inside the subprocedure that they belong to. And so down here, I've got another variable called x, but it's like x in this subprocedure. And so it's going to have no conflict with the other one at all. All right, so I'm going to do this. I'm going to say for x equals, now what did you say? You said start at the bottom. So I'm going to start it at the u-bound of route. So that'll be 35 in our case that we're running right now. To, yeah, I guess this is fine. I'm not sure that the for loop is the most natural one. A do loop might be a little more natural to this, but this will be fine. Upper boundary of route, so 35 to 0. Might have to look all the way up to the 0th position. Now, because we're counting backwards, what do we have to add here? Step -1. Next. And now we're just going to say if if route sub x is greater than or equal to 0, then we'll do something. Greater than or equal to 0. What are we going to do? Exit 4. That'll get us out of the loop. We'll probably do that just on one line. Without having the end if, I'll just do that as a one-line if statement. So we'll start at the bottom, the upper boundary of route, and we're just going to check to see, is that greater than or equal to 0? If it is, we're out, and x will have the value that we were looking for. Otherwise, we'll go through, we'll hit the next, x will go to its next value, one less than it was before, and we'll go through. Okay, question or comment? If x, yes, if x is greater than or equal to, that's what happened. I went to type the equal to, and I typed a 0 instead. Thank you. If x is greater than or equal to 0, or I could say if it's greater than -1, or if it's not equal to -1, any of those things would get me there. Question?
I'm confused. How is this going to grab where we are now and not just the first one?
Oh, the reason that this is going to get where we are now is because let me kind of fill this in one more. Let's get the 7 in here. So I know it's going to pull the 7 here in just a minute, but let's think about it right here. What that loop does is it says start down here, and we're asking ourselves the question: is route sub x, so x is 35, so route sub 35, is it greater than or equal to 0? And the answer is no. And so this expression is false. So we're not going to hit the exit 4. We hit the next, that takes us to the next value of x. We're going to subtract 1 off. So now x is 34. and we ask if route sub 34 is less than 0. No. 33 is less than 0. 32, we're going to keep going until we get to this one. And that'll say, oh, that's why it's going to pick the 7 instead of the 1, is because that's the first one it's going to find looking up this way to get a value that's not -1.
I think I was confusing.
Yeah. The route number, the route number here says which order we're going to it in, and this hotel number says just what's the name, just a way to get to the name of the hotel. Okay, other questions? How comfortable are we with this loop? 0 to 5? 5, 5, 5, 5, 5, 5, 5, 5, 5. Okay. So at this point now, x equals the current hotel. Put a comment here. X is the current hotel. In fact, I think I want maybe a better name for this. I think we're going to probably want X here, but let's just rename this one. Let me dim current hotel as an integer. And instead of using X to loop through, let's just go ahead and use current hotel for this. So now when we come out of this, the variable current hotel is the hotel that we're currently at. Yeah, so that's going to be 1. Let's just test it, make sure that's where we are. So let me just put a stop right here. And I'm going to come up, oh, let's see. Calc route needs to start by initializing our arrays. So when I say calc route, step 1 is going to be go load up the arrays. And then it'll go through to calculate this route. Get rid of that breakpoint. Okay, so now my current hotel is 0. Shouldn't be 0. Yeah. Sorry, my current hotel is not the index number. It's the location at that. Okay, my mistake. So let's do this. Let's just go back to where this is. Oops. All right, when I come out of here, I'm going to change this. Sorry, I'm going to change this back to X. And then let's set current hotel equal to route sub X when we come out. Current hotel equals route sub X. Okay. So now our current hotel is 1. So we're using X. This is, I think it's a little cleaner code anyway. So X, kind of a no-name variable here, is just to iterate across the loop. Once we see the condition that lets us out of the loop, we've identified, our current hotel number is at that location in the route. So now we've just got to find what is the closest, what's the smallest number looking across that row that doesn't correspond to a hotel that we've been to. So we got to figure out how to tell if we've been there. So I think we're going to stop here and we're going to write another function. In fact, been there is so far almost exactly what we have here for next hotel. I'm going to copy this whole next hotel function. And I am going to call it been there. This is going to be Boolean. And here, I think I'm going to pass it in a hotel number. And I just want this function to look across that route array and return true if we've been there, return false if we haven't been there. Now, because this is a Boolean, if I don't tell it what to return, true or false, what's it going to return if I don't tell it? If I don't change it, what's it going to return? It's going to return false unless I tell it to return true. So we're going to dim X as an integer. We don't need to know the current hotel. This is find out if we have been to the hotel number hotel. Find out if we have been to the hotel specified. Okay. So we could go negative through this. I think I'd rather go positive. I think it's just simpler to go up. So for X equals 0 to the upper boundary, don't have to worry about a step. And now, how do we know if we've been there? If route sub X, okay, so route sub X is looking at this value right here. The first time through, we're looking at that. Looking at this, looking at this. If route sub X is equal to the value that we passed in, then we have found it, right? That's like the hotel we're asking about appears in the route. So been there is equal to true, setting the return value. Is there any reason for us to keep looking through the array once we found it? What would we do if we found it again? It's really true. Send back double true, true times 2. So I think we're done here. Exit function. So this is going to say, based on the way that our arrays are currently configured, we're going to send it a hotel number, and it's just going to return true if it finds it. If it doesn't find it, it'll have to return false. All right, so now we've got a way to tell if we've been there. We know the hotel that we're at, current hotel. So I think we just need to look at all of the values that are in that, like in that row for that particular hotel, for our current hotel. Just go ahead and print off the relevant values and make sure that we're getting there already. For X equals 0 to the upper boundary of route. Next. Debug.print X. And okay, so that's the number that we are at. We are trying to go across the distance array. The distance array, and let's look at row number, whatever our current hotel is, and then column number, whatever X is. So that should print 0, 1, 2, 3, 4, 5 for this, and then it should print the distances from Salt Lake. So I should see this, 691, 0, 653, 662. That's the set of numbers I'm trying to process, because this is the one. I've got to find the smallest number here. And if we were to look, we'll see that this one, hotel number 7, which is Las Vegas, that's the smallest number, 425. All the rest of them are bigger here. So, but that's the set of numbers that I want to make sure that I'm processing. So let me put a stop right here. I just want to see what this prints out. I'm going to come up to my calc route, and I'll run calc route. Here's the most recent one, 691, 0, 653, 662. 691, 0, 653, 662. I look down to where 7 is, I should see that 425. So this is the set of numbers. So I don't have to think about my whole array. I just have to think about the row of the array that is the current hotel, the hotel that in my algorithm I'm currently on. So now I've got access to that set of numbers. I've just got to pick the smallest one that I haven't been to. So let's do this. Let's only print it if we haven't been to it. Well, let's do this. Let's start off by saying let's only print it if we have been to it. So if been there, and I'm going to pass it down the hotel I'm currently looking at, then we'll print this. Now, at this point in my array, I've only been to one. I've only been to Salt Lake. So this should look exactly the same, except I'm not going to see this entry because this is the one hotel I've been to. Let me clear that off. Stop this, and we're going to run calc route again. Oh, sorry. That's a, we're only printing it if we've been to it. And so we said hotel 1, we've been to Salt Lake. What's the difference between Salt Lake and Salt Lake? 0. Now, that's only considering ones we've been to. I want to consider just the opposite. So what do? How do I change this to look at the ones I haven't been to? Do I have to make another function called not been there? Yeah, just reverse the choice. Not, if not been there. See if I can run this. So now we should be skipping 1. Yes, because we've been to 1 already, we don't print that. So now inside this if statement, I have access to that whole set of numbers that I have to look at to see, is this a place that I've been? I'm sorry, is this the smallest number? Because I know it's a place that I haven't been to. So at this point, the only thing we're looking at are places that we have not been to. This is a hotel to which we have not been. Okay. Now the trouble is, you guys are used to working in Excel, and so you'd like to say, hey, I just want to use the min function. Like I get the set of numbers, what's the minimum number in here? The trouble is, we don't need the minimum number. What do we need? We don't need to know what the shortest distance is. We need to know the hotel number that corresponds to that shortest distance. So, well, maybe I could do min and then do a match to go back and find it. But we've got to kind of look at these one at a time. I got to notice when I have found like the next smallest one I've seen so far and kind of keep track of that in case it's the smallest one that I've seen. It's the smallest one that I'm going to get. So let's go ahead and take a look. I'm going to declare here a couple of variables. Let me dim short distance as, I think, how do we set dist up as? Do you set dist up as integer? So short distance is going to be an integer. And let me dim that's a short distance. Let me dim, I'll just call this next hotel. Better not call it next hotel, that's the name of my function. Let's call it, I'm going to call this short index. Short index. So the idea is that once I find, like, anytime I find like a distance that's smaller than the smallest one I've seen so far, I want to remember the index where I found it. So as I'm coming, if I think about how I'm coming through here, I'm going to say, what I want to do is say, oh, 691, that's the smallest one I've seen so far. Remember that 0 is the hotel that I found that at. I'm going to skip this one. I'm going to look at this one and go, oh, 653, that's smaller. Remember that value, and remember that I saw it at 2. Then 662, that's not smaller. 659, that's not smaller. 650, oh, that's smaller. Remember that that's the smallest value I've seen so far, and I saw it at number 5. We get to 661, and that's not smaller. 425, oh, that's smaller. Remember that that's the shortest distance I've seen so far, and where did I find it? I found that at number 7. And as I look across the rest of these, I'll never find a smaller one. So we need to do something so that the very first time we read a value, we say, oh, that's smaller than the one we've seen so far. What can we do? What can we do to say the first time we make a comparison, Like the first time we go to print this number off, we just go, oh yeah, that's the smallest value. Because I've got to record, we've got to remember both what the shortest distance I've seen so far is and where I saw it. Let's do this. I'll print it out, and I'm going to say if the value that I'm currently looking at is less than short distance, then we have found a new potential shortest distance. But the trouble is this the way I have it right now? Will this ever be true? Why not? Yeah, short distance is 0. And my only 0 is a place that of necessity I must have already been to. So what do? Oh yeah, let's just set this thing to something really big. Let's just start short distance off. Something that's so big that no matter what we look at first, it goes, oh yeah, that's shorter. Short distance equals 32,768 or 67, I think, is the maximum number I can put in an integer value. But you know what? I'm happy with 24,000. The circumference of the Earth. What's the likelihood that I'm going to find a distance that's longer than going around the whole Earth? So now, because short distance starts as something really large, the first time we check to see if a distance we're looking at is smaller than our short distance, then, that must be. And so what do we need to do? We need to remember 2 things. We need to say, that is now the shortest distance I've seen. So the shortest distance is equal to whatever, dist. The short distance is equal to that new shortest distance that we've seen so far. And I want to remember where I saw it. So that's the whole point of this short index variable, is to remember that I saw that at X. So I'm remembering these 2 things. When I see a smaller value, I'm remembering what that value is, and I'm remembering where I saw that value. So this, because I'm comparing now 24,000 to 691, I'm going to remember, short distance is now 691. Place where I saw it is 0. Here's another one, it's smaller. My short distance is 653. Place where I saw it is 2, not smaller. 659, not smaller. 650, short distance is 650, and where I saw it was 5, not smaller. And again, we pick it up at 7. By the time then we're done with that loop, all we have to do is send back our short index. And the name of our function is next hotel. I'll stop my code, get rid of that, stop right there, and let's put a stop here. Okay, if that worked right, we should have gotten 7 right here into my route. All right, what do you want me? Do you want me to pause right here for a minute? So this is the hardest part. It's like looking across that and saying, how do I know, is it one I should be considering? Well, if it's a hotel I haven't been to, we're going to consider it. And how are we going to know if it's one that we should consider? Well, if the value that we're currently looking at is less than the smallest one we've seen, that's a potential. Keep track of where it is. Each time we see a smaller one than we've seen before, we'll remember where we saw it, and then just send that number back. So now I think I'm ready to get the next location. You get the next 2 positions. And let me just ask if that makes sense. So I'm gonna show route sub 0. In fact, let's show the hotel at that location. That should be Salt Lake. The route sub 0 should be holding 1. So hotel of route sub 0 should tell me Salt Lake. When we look at the next position, this should be Las Vegas. Let's see if the next one makes sense. I have no idea where Fairplex is. Where's the next one? Anaheim. Okay. So we started in Salt Lake, we went to Las Vegas, and down to Anaheim. That seems pretty reasonable. So it looks like we just need to give ourselves a loop that will do this. Well, that's the thing that arrays are great for, is looping. So we go ahead and run this out. We'll declare a variable x here. I'll do it after I initialize. Dim x as an integer. I don't want this inside the loop because this is how I start. So for x equals, and it looks like my vector is going to start at 1 and go up to my largest hotel number, where x equals 1, 2, the upper bound of route. Now I don't need all 3 of these in here because now x will go up each time. So the first time through the loop, x will be 1, then 2, then 3, then 4, then 5. I think I'm ready to print off kind of after we do that. Let's go ahead and have another loop similar to that one, but this one's going to start at 0, and it's just going to print what we had right here. So that should print off the route. Wow. Didn't take us long from the time we got the first one. I calculated, it didn't take us long to finish it off. So I think when we run this now, it'll calculate that route. Let's just run it and let's just see. I'm going to go ahead and get rid of like a bunch of the other debug.prints that I had in here. So when I'm initializing, I'm doing some printing. I guess I don't really want to print that one. I think I was printing when I was down here in next hotel, debug.print. Okay, so I think the only thing it's going to print now is going to print off like the actual route. Okay, start at Salt Lake, go to Las Vegas. Fairplex. Well, we'll go to Anaheim. Fairplex must be pretty close to Anaheim. This is, oh, let me print, I'm going to print off my x as well. I'll just print x plus 1, which will give me the stop number. Okay, so start at Salt Lake. Stop number. Oh, I want the hotel number too. I also want route sub x, which will tell me the hotel number. That looks good. So 1, 7, and then go to 12. So let's just go look at Hotel 12 and see if we can find out something about where it is. Oh, maybe it's on the properties. Hotel number. I don't see the numbers here. So those aren't going to help me. Oh, let's go to my arrays. Number 12. And can I see something about who it's close to? It's kind of close to 41. Yeah, I think we're just going to assume that that one's in that same neighborhood. So we go to Anaheim, also in Anaheim, Cerritos. Anyone familiar with the San Fernando Valley? Cerritos, kind of close to Anaheim? Yeah, it's in there. It's not far away. Long Beach, also there. Los Angeles Airport, still right there. LA area, Beverly Hills, LA area. This looks pretty good. Los Angeles, Monarch Beach. I guess that's still LA area. La Jolla, not LA area. Where is this? San Diego area. Okay, so we're going, that's not bad. We're doing a bunch of stuff in Los Angeles. We're going down to San Diego. San Diego, San Diego, San Diego. Palm Springs. This is kind of the first one that I get to, and I think, I'm not so sure. Palm Springs? It did mean Palm Springs. Here's Palm Springs. Yeah, that's no good. So what do? We came from Las Vegas. We came down here into Long Beach, Los Angeles area, down to San Diego, back to Palm Springs. Might have been better to come to probably better to come to Palm Springs, then to San Diego, then up. But so far, so good. I mean, it's not terrible. Bakersfield, so Central Valley, San Jose, Bay Area, Silicon Valley, Bay Area. I don't know about that one. San Francisco, Bay Area. We have Montreal. This is the one that has the wrong address. It's not really Montreal. San Francisco. So it's not bad. At least it's getting these clusters. Well, San Rafael, also Bay Area, I think. Sacramento. I don't think you call Sacramento Bay Area, but it's close. And then we're up to Seattle. I don't know where that one is. Ooh. Who knows where Scottsdale is? Arizona, Venetian, Phoenix Airport Hotel, downtown. Okay. So pretty good until we went up here and then said, oh, you know what? Let's finish off by going to Phoenix. What would have been much better for this? We got to start in Salt Lake. Probably hit Las Vegas on the way to Phoenix. Do whatever is happening in Phoenix over here to San Diego, then up the coast. Yeah, you see what I mean when I said you can do better with a pencil? And this wasn't so much about trying to solve this age-old problem as it was, let's get some experience working with arrays. Let's just do one more thing. Let's just give a different starting point. What happens if we start in Phoenix? I wonder what it's going to look like if we start in Phoenix. So how do we start? Scottsdale. Let's start at number 3. Start at 3. This says start at Scottsdale. Does all of these that are in Phoenix area, then goes to Palm Springs, then goes to Anaheim, then it's going to go to San Diego, get it back up the coast. So, but we can see now that we could kind of quickly calculate lots of different possibilities depending on where we start. So this has been an introduction to the idea of arrays, and they are, of course, arrays of variables. A couple of things to point out here is that, and this is like the reason that you want to make sure you're using the right data type, because you create an array that's got tens of thousands of variables. Having a data type like variant with 22 bytes of overhead now could make a difference to you, to performance on your machine. Okay, I think that's it. Thanks for coming. We will see you on Wednesday. Class dismissed.